Started. Hey everyone, welcome. Thanks for coming. So we're in a stratagem on strategy. This is really about rolling security testing into existing product testing. We'll explain, obviously, through this what that means. So quick introductions. I'm Kevin Feely, Josh Wallace. We're both with EY, Ernst & Young. We've both been in AppSec for a while. This is the second time that we're co-presenting at LastCon. This is my 6th time presenting here. It's an awesome conference with great barbecue, so just keep coming back. I like to try to think of security as an enabler for development, and therefore I like to try to keep myself informed on what's happening on the development side, and that extends now into sort of infrastructure as code side, so I do multi-domains. I'm interested in everything that goes into sort of product development, and I think the more that we can merge all of those together and work collaboratively, the better off we'll be. So I'm all about unicorns and green fields and rainbows, and I try to make that sort of the vision of where security should be headed towards, right, of just let's move towards the ideal as much as we can.
Relatively the same for me. Been doing this a long time. I started off as a developer, moved into application security and finally into consulting. So I've seen this from all sides, kind of seen the pros and cons from all perspectives. Really passionate about DevSecOps and mostly just coming out to people like you and trying to change your perception on how to do security testing, to give you some new ideas and some different things to try, as opposed to automating static analysis and things like that. Kind of odd for a consultant. I am married. I do have 3 kids. They're getting very old. My daughter's almost 15 and is starting to talk about driving, so I'm a little nervous about that. And Kevin didn't mention it, but he likes WoW a lot, and ArcAge is totally better. So if anybody's playing ArcAge unchanged, let me know.
So as I mentioned, we're going to talk about QA here, quality assurance, what that means. We're going to talk about security assurance, what that means, how the two are similar, how they're different, how we can sort of move them closer together. And we took basically the key takeaways, like our themes for the presentation, and just move them up to the front. And we'll talk about them again later. We'll hit on them later. But just so you have sort of a perspective of where we're heading towards and what we want the takeaways from this to be, QA right now is really valued in most organizations that are doing software development. It's sort of a given that you're going to do QA, that you're going to do it well, that it's going to be a very disciplined process, that you're going to have measures, you're going to have metrics, and you're going to have measures for what is your test coverage, what percentage of tests are passing and failing, are you meeting your requirements or not? And all of those are generally pretty strictly gates to being able to release a product because the customer experience is valued, and most organizations will recognize if the customer experience is not good, right? If there are bugs, if the software is not easy to use, then you'll probably lose customers. Where on the security side, since security is often not really seen as much, and customers don't really know if the application is secure or not, and you can just say we follow industry-leading practices and use bank-level encryption, customers will generally be okay with that, even if there's no actual security under the hood. And so security isn't as valued in organizations because it's not as visible. So how can we make security more visible and more consistent to increase the perception of value within organizations, to improve investment, and actually move security forward? That's what we want to get to here. So this is an opportunity to learn about QA and to learn about how security can be a little more disciplined and move closer to QA to add more value and hopefully ultimately get you more, from a program perspective, more money to do more things.
All right, so let's talk a little bit about what security looks like today. Give everybody a good baseline. So security is generally measured by maturity. If any of you are on a security team, you probably have several maturity models that you've used. You've probably hired consultants like us, to come out and tell you how mature you are. Maybe your security program for AppSec started as part of an audit where some auditor came out and said, hey, you don't have AppSec, but you have all these firewalls. Maybe you should start off with doing a pen test once a year or something like that, and you get some kind of curve, to improve your level of maturity. But at the high end, mature security assurance programs generally take a risk-based approach. We know at least a little bit about our applications. We know which of our applications are putting money on the wire. We know which ones can cause the biggest impact to our business, right? We probably have some sort of a business impact analysis that tells us that. And our security activities are generally tailored to that, right? Our critical programs get more testing. They get more pen tests. They get more dynamic and static analysis done. Maybe we're doing threat modeling on them, right? We're throwing the whole kitchen sink of security activities at those applications. Whereas, say, maybe an internal brochureware type of site is getting very little, if any, security activities. Whereas we move over to the less mature programs, and really the biggest indicator here is that everything's getting treated with the same level of security, whether that be a lot of testing or very little, right? Generally our applications are treated the same. Generally still doing, SAST, DAST, etc. And our manual penetration testing is generally happening for compliance reasons. Next slide, please.
So there's a big difference between mature and immature AppSec programs, right, in general. So does this resonate? Do you all agree that you have a steep maturity curve sort of in the AppSec world to say that there's a big difference between a mature and immature program? Show of hands. Yes? Yes? Okay. I'm assuming the people who didn't raise their hands just aren't engaged, and you agree. Okay.
All right, so quality assurance, we find pretty much exactly the opposite, right? A high maturity quality assurance program looks very similar to one that is low maturity and just starting out. Right, a mature program has various activities, right? We're defining in our strategy, architecture, scope, dependencies, etc. We have formalized test plans. We're using test case management. In a less mature program, we're doing all of those very same things. Really where we differentiate between the two is more in the scale, right? An immature program who's, I don't know, maybe they've been doing QA testing for the last year. Maybe they have, I'm just making up numbers, right? A dozen, 2 dozen test cases, something like that. Whereas maybe a more mature program that's been doing it a long time has, hundreds or thousands of test cases. But at the end of the day, the processes that they're following are the same, right? They're following the same standards, the same workflows, the same processes.
Yeah, so this just really demonstrates the value, right? Because if you're standing up, whether it's a startup or a large organization, and you're going to start doing some software development, there are core foundational things that you're going to build into your program, regardless of how much you're going to get investment to do it because it's assumed that these things need to be done. Where on the security side, it doesn't really happen. I'll go to clients and I'll say, you should be embedding security resources into your development teams to help review stories and identify risks and identify required security controls and continue that thread. And the response I'll get is, yeah, that's great, but that's for a more mature program. We're not quite there yet. But you don't get that on the QA side, right? On the QA side, it's assumed that you're going to have test engineers embedded with the teams, that you're going to have a lead test engineer who's helping to build the security strategy and maintain consistency across all of your software development. So it really comes down to sort of the perception of what's the value of security, what's the value of QA. And QA is valued, whereas security on paper is, but in practice is not really yet, at least yet.
All right, so quick summary, right? Security versus quality assurance. So our security assurance is relying on tools that are designed to test the baseline security of applications out of the box. And our testing is really driven by vulnerability detection and identification, right? So a majority of the AppSec programs that we see are very vulnerability based, right? Organizations are pretty good at, hey, we've got 20,000 vulnerabilities. 10,000 of those are criticals. We're getting better at finding them. Last year we only had 10,000. So obviously our program is getting worse. We're also generally tracking them as individual vulnerabilities, rather than anti-patterns and individual problems, right? If you take, any of these security tools or whatever, or even the results of a pen test, right? It's going to say things like, hey, we found, X number of cross-site scripting vulnerabilities in your application. Now, hey, developers, here's a big report. Go out and you need to fix X number of cross-site scripting vulnerabilities, without taking into regard that those tooling and testing techniques probably missed a whole lot of vulnerabilities that you're not going to fix then. Quality assurance, really the big difference here is testing is driven by requirements and controls validation. So you're defining what your requirements are in a QA strategy, right? Then you're identifying controls that will satisfy those requirements, and then you're testing for presence and effectiveness of those controls, and then reporting back essentially on whether that requirement was met or not. For anybody that does QA testing, I think that's pretty much a given, because that's just how it's done, right? But security, that's not how we think about things, right? We think about things in terms of vulnerabilities, because that's what our tools and techniques are good at detecting.
Right. So if we were to poll the room, I would suspect that across your organizations, you probably have, 10, 15 different languages that are being used, in the room, different frameworks, different architectures, microservices, web apps, mobile apps, right? There's all different types of applications, and you're all probably using the same tools, right, to test them, and they're all being designed. It's an industry problem. Don't mean to imply fault on anyone, right? That these tools, we buy them out of the box and we expect them to work on all of these different architectures and languages and frameworks, and we expect the tool vendors to figure out how to do that. It's just not reasonable, right? Your applications are all custom built for a reason, because they provide custom functionality that meets your business's needs. On the QA side, they don't have that expectation. They buy testing frameworks, right? Like you've probably heard like Selenium, right? Or JUnit, or right? These tools that are frameworks that enable you to write your own tests, to test things that are important to you based on your languages, based on your frameworks, based on your tech stack. And so there's just sort of a difference in our expectations of vendors. And the more mature industry, which is QA, they're not following the same patterns that we are of thinking that vendors can sort of produce these out-of-the-box solutions that work across the board.
All right, so let's look at a very basic QA testing framework. So generally starts with requirements gathering, and you'll see that kind of flows all the way to test reporting. But generally your QA is embedded inside of your product teams. They're involved from product inception, to sprint planning, all the releases all the way up to your final release, and then some as the product continues to evolve. They're reviewing, all the requirements, all of the user stories. They're helping to identify them, and then they're building a test strategy based on that. So they're using that information to then come up with a test plan, which is where they start. Well, we'll have some slides on this later, but they start writing, the Gherkin, type of scripts, to put out in plain English, what that test should look like and what it should perform. Test development is where, a developer or a QA analyst, is actually writing the code, behind the Gherkin that's actually doing the test execution. At some point, we execute the test, likely repeatedly as part of our build or our release process. A lot of times, these are, gates that we have to pass to release our code. And then finally, we have reporting, right? And the important thing here is that our requirements feed back into our reporting. The reports that come out of this are specific to those requirements. So we have direct line of sight and traceability, going all the way from our requirements to the reporting, which is very important here and a key part of our message that will hopefully come out. Security is really only doing those middle three, right? The test planning, test development, and test execution. I actually had a long conversation with Kevin about this last night. I would even argue that security is doing the first two of those, pretty poorly, right? A lot of us say, hey, we need to have a pen test because we have to, or because we're going to have a release, right? And our scope is going to be, this application, don't leave the subdomain. There you go. Give me a report back, right? We don't put a whole lot of thought into the planning. Even when we start talking about tools, right? It's just, hey, let's stage up our favorite tool and let's scan all of our applications and let's scan this app, right? Oh crap, it has authentication, so it didn't get past the first page, so I've got to configure authentication. Hey, great, I've planned out my test, right? And then it runs for 4 days, and then you get 20,000 vulnerabilities back. So the important thing is we want to shift this, to where security is doing everything, right? We're doing thorough planning, test development, requirements gathering, reporting, and we'll circle back and show you how you can do all of that. So, I'm going to kind of give you an example here of what we're talking about, because I know this is all kind of, fluffy and high level so far. So, going to give you, 2 examples, right? The first one is clickjacking. Everybody relatively familiar with what clickjacking is? Okay.
There were some no's. There were some no's.
Nope.
All right, so clickjacking it's an application level vulnerability. This feels like a test now. Clickjacking is an application level vulnerability where essentially you're able to insert a frame, basically another application on top of the application the user is using. And so when they click on something that they think they're clicking on one thing, but they're actually clicking on the application on top of it. So the prototypical, very old example is you put a banking application on top of a little game where the user has to click on a bunch of buttons and then put in some really big numbers. And what they're actually doing, it looks to them like that's what they're doing, but there's a transparent frame or application on top of that application, and they're actually transferring a whole bunch of money, right? Because their banking application is sitting on top and they're logged in, so the session is there, that type of thing.
So, that's a perfect segue right there, right? Because we have this guy here on the left, right? You get your pen test report back, you run a tool, whatever. It says, hey, you've got a clickjacking vulnerability, right? Precisely what this guy's saying here, right? What the hell is clickjacking? That's a very security-centric term. It means something very specific, and especially when we take one of these reports and give it to our developers and tell them to fix a clickjacking vulnerability, right? Again, that's a security-centric term. They might not have any idea what that actually means, right? And if we read through the description here, it's not all that more obvious, right? It was observed that the application does not explicitly prevent or deny clickjacking style attacks, also known as a UE redress attack, right? That's not helpful. Also, the key thing here is to say if we do pay for a pen test, have some really smart people come out and try to break your application, and the final report that they give you doesn't have a clickjacking vulnerability on it, or say you run a scan and it doesn't have a clickjacking vulnerability, that doesn't necessarily mean that you don't have a clickjacking vulnerability in your application. It just means that it wasn't discovered, with the testing techniques or, within the scope or time box that the test was performed, right? So it's a false negative. Right, and then over here on the right, is more so, what we're proposing today, where we're going to take a more QA type of approach to this. So our requirement is, right, doesn't say anything about clickjacking is the first thing, right? But X-frame options header shall be set to deny on all HTTP responses. It is recommended this be performed by the load balancer. So a couple of important things here, right? So again, first of all, we didn't mention clickjacking at all. Second of all, the developer now knows if they're reading this requirement, they know exactly what they need to do, right? They know that they have a header that they need to set in their application or ideally on the load balancer to do this for them, right? They know what the requirement is, they know what the security control is, and then they also know the answer to the test that they're going to be given, right? So that when this, the test case for this is run, they know how to pass it. Also, it's implemented right the first time. And if it's not, they have very clear guidance, right? So if, again, a pen tester comes out, tells you have a clickjacking vulnerability, one of the things that we do frequently is retest, if we do a vulnerability, because we tell developers things like, go fix this clickjacking vulnerability, let us know after you fixed it, we'll do a retest, and we'll tell you if it's actually fixed. A large portion of the time we go back out there and we retest it, and they still have the same vulnerability because they only partially found it, or they went to Stack Overflow because that's how developers write code. And they didn't implement the solution right the first time. Also, very few false positives, right? Because we can write a test case that will test specifically for the correct implementation and configuration of that header. And more importantly, we get that traceability back. Again, it's not you have a clickjacking finding. It is we have a security requirement that you will implement this header in this way. That security requirement failed. So to give a different example, I like to talk about cross-site scripting with this, just because I hate scanners and tools that are testing for cross-site scripting. Right? So generally, the way these tools will work is you'll point them at your application. They're going to go out. They're going to do a crawl. They're going to map out all of your application, all your GET requests, all your POST requests, all of the responses, etc. It's going to find all of the user input, right? All of your cookies, all of your query strings, all your post body parameters, etc. And then it's going to inject approximately a half a bajillion malformed inputs into there, right? You've all seen, the less than script alert, etc. And then there's just an infinite amount of payloads. So the scanner's going to do that to all of the inputs to your application, which is time consuming. If any of you have ever run dynamic analysis, especially on a large application, you might have found that it takes sometimes days to run. And that's part of why, right? Because it's creating all of those payloads. It's actually changing the payloads every time. Each test might have a different set of arbitrary payloads. Well, if we change the approach from, hey, thou shalt not have cross-site scripting in your application, which we can never guarantee anyway, right? Instead, we say our security requirement is, I'm going to make something up, right? You don't have to follow this. Don't write this down. Something like, hey, you should use OWASP SAPI framework, configured in X way to prevent cross-site scripting vulnerabilities in all of our custom developed applications. Right now we can write a test case, that will look at your web config file or wherever in your application, and you'll look for the presence and proper configuration of OWASP SAPI. And then we can say we are meeting our requirement and we are following the company standard for preventing cross-site scripting vulnerabilities inside of our application. And then when we put that on a report, back to our CISOs, right? We can never, ever, no matter what our management wants to think, right? We could never guarantee that we're free of cross-site scripting. But we can guarantee that the control that we outlined is in place and working properly and mitigating it, based on our requirement. That was a lot, sorry.
Yep. So what does this practically look like? We're going to get more and more practical, and we're going to get to an example to sort of try to solidify this in a minute. But test strategies is sort of the first step. So we talked about this a little bit earlier in the process. Security generally doesn't have much of a test strategy. We might have requirements, we might take a risk-based approach, and we might treat applications differently and say that these applications need manual pen tests and these ones need threat models and architecture reviews and with this frequency. But we don't really go to the same level of documentation and granularity, especially at the product or application level that QA does, right? We're still looking for sort of program or enterprise-wide solutions. And there are various reasons for that, one of which is staffing, right? We typically don't have the numbers to really embed and go to the level of looking at every application. And so, again, that goes back to value, which hopefully eventually would be resolved. But test strategy is the first step that QA takes. And they look at the application itself, and for every product or application that they build, they write a test strategy, which in my experience is usually 100+ pages and describes the scope of what testing will be. It describes the environments where we're going to test. Are we going to test in UAT testing or SIT or integration testing, like what types of testing are we going to do? What are the environments we're going to test in? What are the roles and responsibilities for testing? So I've got this, like sort of some of these on another slide. But there's a whole lot of detail that's determined up front that's built in collaboration with the product teams so that everyone is on the same page. There's knowledge sharing about what we're going to do to make sure that this application or this product is ready for our customers. And that's really important because you have now a centralized knowledge share where if you have QA team members who come on the project, go off the project, developers join, leave the project, you get a new product owner, right? You have a centralized knowledge share of this is our approach, this is what we're doing, and it makes sure that there's consistency between, you might have multiple QA testers or QA engineers within the product teams. Now you have consistency that they're all following the same methodology, they're all on the same page, right? I don't think we have that from a security perspective, right? If I pen test an application, well, I'm not going to find anything because I'm not very good at pen testing. But if Josh pen tests the same application, he might find more because he's better at it, right? That's an inconsistent process, and we're not delivering consistency. We're not really delivering our value. QA is much better at this because they get granular and define exactly what they're going to be doing. I think we got dependencies and constraints, roles and responsibilities. A lot of these will have architecture diagrams that come out of the design phase, and the testing plans and testing strategies are built based on that. I think we would really benefit from that from a security perspective. Like how often do you go into a pen test or a code review or an architecture review and you've got really no inputs except for like a running application or the source code, right? That wouldn't work for QA. They go in understanding what is the core business value of the application, what is it trying to accomplish, who are the users, what are the roles, what does the architecture look like, all of the components, how do they connect, and they can build their tests based on that. So we're sort of at a disadvantage. Yes?
I think one of the key points is during that Q&A development process is there's not a lot of tension when you're developing your test cases. It's true collaboration and stuff pushback.
Yeah.
Security, where to sit in that same room and try to develop it, that's where you're going to get more of that headache and pushback.
Yeah. Yeah, and I mean that will be one of our takeaways later is exactly that is right. Security should be part of this process from the beginning. So the programs that I like to work on, we're part of PI planning, the program increment planning that happens before sprint planning, right? And we're part of sprint planning. And so as stories are being developed and prioritized, we're there to hear them, to figure out sort of on the fly what are the potential risks and what they're describing they want to do, and to tell them, here are some considerations and controls that you need to make sure are part of that. And we'll show you what that looks like. We're gonna go there in a minute and show you a feature with functional requirements and then what the security requirements will look like tagged to that. And if you do it that way, you're right, there's no tension because you're part of the process. The problem is when security comes in later and says, well, now we're gonna run a scan, and you don't really know what that scan is doing, but if we find vulnerabilities, you're gonna have to fix them, right? It's a very, it's not a great process. Is that sort of what you meant? Yeah. And feel free, please, anyone else, if you have questions, please raise your hand or just call out. That's fine. I appreciate that. Thank you. Right. And then so what's the acceptance criteria? How do we know if this application can go to production? This is an interesting one from a security perspective because our elevation criteria is often very arbitrary, right? Like you can't have any medium or higher findings. You can't have any critical findings. You can't have any authentication findings or session management findings. But it's like, what is the objectivity? What's the basis for how we've determined this? There is none. It's entirely subjective. It's based on leading practices that were developed over time without the discipline that's present typically in QA. And that's what we want to move closer to. If we can link back to requirements, then we can determine what's the threat model of the application, what are the real risks to us being able to conduct business using this product, and then we can prioritize those risks and determine these are the risks that we can't go to production if they exist in our application. And these ones we can live with for a short time and we'll fix them eventually, right? We're trying to add more objectivity and discipline. So we'll move on, but just want to ask that question. Does anyone currently do this? Does anyone currently contribute to a test strategy within their organization from a security perspective? You do? Yeah? That's fantastic.
Nice.
So
Yeah.
we have like security requirements, but most of the strategies what you're talking about would work for if you have a large number of security people. So we started creating security requirements.
Yeah.
Now the problem I feel is like, hey, you have created a lot of security requirements. How do you solve those?
Yeah.
So I strongly feel that you need to integrate a lot of automation into this process. And the previous slide you're talking about, okay, let's start getting into QA and write test cases. But what if you have only manual test cases?
Yeah.
If you have 100% coverage on QA, automated testing, then a lot of these things would be solved. But if you have manual testing alone for a product,
Yeah.
then you have just one QA person working on that product. They're not going to concentrate on security. Their goal would be concentrate on functionalities because that's what they're paid for.
Yeah, so that's a good point. So I'm not expecting QA to be doing this security testing. And some tests won't be automated. They will be manual. But that doesn't mean you still can't define what the tests are beforehand. It is more work. It is more time consuming. And one of the biggest issues in security teams is resource constraints, that you don't have enough people to actually do all of that and scale it. But you have to start somewhere, right? So if you could say, all right, let's pilot this with one team, try it out, prove it out, and then we'll show the value. This was, we reduced the tension with the product teams, and we have measurable security coverage that we can show you that this is secure. I think this is the road, the long road, right? We're talking 5, 10 years, who knows, to show the value of security, of how security can be embedded transparently with more discipline like QA to eventually get the investment and get those additional resources. This is not a problem that gets solved overnight. This is a very long road that requires a culture change and process changes and skill set changes within the security teams to better understand development, to better understand Agile if you're doing Agile, what that process, and yeah.
I have seen success in getting QA to run those user stories when they're developing their functional tests. Since they something like Selenium, they know that, they know how to work within it, and a lot of the security team doesn't. But we know how to define the story of what we're looking for. We've had good success getting them to write those stories and just make it part of the process.
Yeah.
Yeah, we need to train QA people. That's the only way you can extend the time. That's totally agree.
You said to be friends.
Yeah.
Yeah, there's a lot of strategies on how to scale security as a whole. I mean, yeah, absolutely, if you can leverage QA, that's really helpful. Being friendly with them, that's one of our next steps at the end is get to know your QA person. You can work with security champion programs. You can have developers. We've had developers who write security tests, integration tests, end-to-end tests, unit tests. But it requires a culture change. It requires flexibility and a commitment for everyone that we're going to invest a little bit here to change the processes, to change the norm for the long-term betterment of our organization. Did you have a question? Yeah.
Well, I was just saying that just training the QA is really after the fact.
Mhm.
You have to train the developers so that they write it correctly in the first place, so they don't have to rewrite it.
Yeah.
And so that's why we're here.
So I would phrase it differently because I don't think it comes from, personally, I don't think it comes from training. And sorry if you want to speak up too. I don't think it comes from training as much as it's informing them. It's awareness of these are the things that we're expecting from you. So if you try to tell someone, this is what cross-site scripting is and generally how you prevent it, that's helpful. But if you tell them you need to use input validation using a SAPI's input validator or using this particular library, and you give them very prescriptive, clear guidance, that's really how you make sure that it's there. And that gives you the ability to verify later that they're meeting those requirements. But you're right, everyone through this process needs to be better informed, and there has to be better knowledge share. I just personally don't believe that training, use this room as an example, right? 6 months from now, how much of what we're talking about today are you going to remember? You're consuming a lot of information between now and 6 months from now. So I don't think people generally have the retention unless it's very prescriptive and specific. That's my personal viewpoint, though. So, although everything I say is so.
And I think we've been proving for about the last 20 years or so that security training is not working, right? A simple example like SQL injection, a very simple fix, right? Any developer that comes out of school today, should understand how to write a prepared statement. But it's still our biggest, most critical vulnerability, right? We're making very little progress in getting developers to fix security issues. And, a large part of that, I think, is what you're going to talk about in a minute, and it really comes down to, the friendliness, but also just the language barriers, right? Because, going back to the previous example, there's a big difference between training them on clickjacking, and teaching them exactly what it is and how it can be exploited and, all of the common, industry accepted ways of preventing that vulnerability and hoping they don't copy paste something wrong, and explicitly telling them, hey, set this header this way, right? They don't necessarily, it's great if they understand why, but they don't need to have any understanding at all of clickjacking here, right? They just have to know that what they're going to be graded on is, did I set this header, right? And then they pass or fail the test.
You know. Making me sound like developers wouldn't understand what that was, which is untrue.
So
I agree.
developers have a lot to learn, right? Okay, that didn't come out right. Developers have a lot of information that they need to pick up and maintain and turn into action, right? They need to learn new languages and frameworks, new algorithms, new ways of doing things all the time. I don't think it's realistic to say, developer, you also need to know everything about security, right? Just like I wouldn't expect it to be like, you don't need to know all of the sorting algorithms and the searching algorithms and which ones to use in various cases. That's not your core competency. It's our job as security professionals to enable the developers to build secure applications and to verify that they're secure, but it's not necessarily their responsibility to know everything about security. As long as they're doing what needs to be done and building their application securely, they're doing their job. So there are various ways to do it, right? But I don't think they need to. If they understand clickjacking, that's great. But if they don't understand it and they're still meeting the requirement, then who cares if they know what it is?
Well, to his point too, most of the time they're concerned about functionality.
Yeah.
You input that in that header space, or even getting the more advanced content security policies, stuff's gonna break, right?
Yeah.
So, and if it's not defined, you've got stuff that's 12 years old, the developer that built it's all long gone, and not very many people have the documentation to really drill down into what all this touches.
Yeah.
You're gonna butt heads. There's
Right.
gonna be problems. So you gotta have test cases built to be able to validate that when you put that in, nothing's breaking deeper down in your application.
Right, and that will happen if you're integrated with QA because they're doing regression testing to making sure that to make sure everything is still working, right? So you'll find those problems early on, right away, maybe on the developer workstation before any code is checked in, or worst case in like an integration environment. So
Hopefully your testing environments are as close to prod.
Yes.
Not exactly prod,
Yes.
but
that's a whole nother problem.
Sometimes it's prod and stuff is there that wasn't in the test.
Yes, yes, yes.
I
We,
think there is one way we can solve this problem, like how React and these modern frameworks are taking those approaches,
Mhm.
process scripting, right? If
Built into the
similar
framework.
kind of an approach has been taken by all the languages, like for example, if I'm creating a SQL statement, by default I can only create prepared statement. So what will happen is, by default it is trying to make sure that you write only secure code.
right.
Unless and until we have such kind of frameworks and all the languages adapt that thing, we can take different approaches, but we can't match the speed at which the developers writing code.
Yeah.
Because today you will write something which test cases related to external options. Tomorrow, browser will be coming up with another set of data. Hey, you have same site. Okay, I have to search for same site now. This is going to be like catching a horse just by walking.
Right.
You can't even catch a horse.
You're right.
That's the problem we have now.
We have to keep our requirements up to date as technology changes. And developers and everyone, it's human nature, right, to take the path of least resistance, the easiest path. So making it the default, the only way to do something, also the secure way, is definitely what we want to encourage. Yeah. So just to be a little bit more concrete, and thank you for all the collaboration, I appreciate it. I think it's more valuable for everyone. To make it a little bit more concrete, this is just an example of a snippet from a security strategy that we've collaborated in. And I wanted to just, when you go and look at security strategies, this is sort of some of the places that you might start, right? Does security want to contribute to what's the scope of testing overall? What is the approach of testing? What's the automation strategy? So these are just some common sections in a test strategy and where you might be able to contribute or add value from a security perspective. On the right, you could see this is component integration testing. This is the description of what that type of testing is, who's responsible, what the approach is, and you could see that the exit criteria to leave integration testing, it includes that we're testing for security vulnerabilities and adherence to security requirements. That may or may not be part of your existing test strategies, and you may want to provide feedback that it should be. Or you can be more detailed right here. But the point is that we should probably be making sure that security testing is part of these and not just some sort of an add-on that's not really documented that people don't know about. This is also, the test strategy is also a really good place to establish a common taxonomy. This is a problem in a lot of organizations where just someone says authorization, someone else says access control. Are they talking about the same thing? Are they not? Right? So using the same language in here, defining your terms, gives everyone from development, testing, everyone who's using this document, a common place to look and understand what everyone's talking about. Did you want to talk about this one? So QA is a valued mature function in most organizations, is well understood by developers, and clearly demonstrates test coverage. These are the things that we had on our opening slide that we said are sort of our key themes. We're just revisiting them to sort of make sure that we're communicating what we want to communicate. These are what we want the key takeaways to be in the presentation. We are going to, again, go a little bit more concrete and more detail in the next slide. But security generally does not provide a measure of test coverage. Are we all in agreement there? Does anyone think security measures test coverage really well? No?
Are any of you a pen tester?
A little bit?
Yeah, okay. One of the challenges I recently had was, oddly enough, a CISO was on a readout call that I did for a pen test. And one of the things that he told us he wanted to know, on the call was, well, what exactly did you test? Right, and for everybody who's ever read a pen test report or done a pen test, that's not something we answer, right? We have a general scope. We say we're going to test, I don't know, the OWASP top 10 controls, right? We're going to test these broad security categories. We're going to take a wide swap and try to hit whatever we can in your application. We might hit 25 out of 100 screens. Maybe we hit all 100. Maybe there's 50 more that you didn't tell us about that we don't know existed. Maybe we didn't test every input. But the point is that, on that call, the CISO asking this, could not explain, outside of, well, we tested all the common security controls, we tested for common security weaknesses, but could not give him, a prescription of every individual thing that we tested and did not test, because that's not how we operate in security today.
So QA does, though, obviously, right? That's the theme here, is that they can give you a discrete measure of coverage of this is the percentage of the application covered, these are the functions we looked at, these are the lines of code that were tested. And it would be nice if security can get to that point. Security is confusing to people outside of security, right? We use different taxonomy, different language, different terms for describing things, which is reasonable, but we have to find a better way of communicating. And this is an opportunity, right, for security to better integrate into QA by really understanding what they do. And this is really what DevOps is about, right, is we're all working together. This is where rainbows and unicorns and green fields come. We're all working together and collaborating. We have cross skills trained, so I know a little bit about QA. QA knows a little bit about security. Developer knows about each of them. We all know a little bit about ops. And we're working together for a common goal using common methodologies, and there's consistency across how we're doing things. So this is I'm sort of spoiling because we have a slide later about is this compatible with DevOps. But yes, this really fits in well with DevOps. And really what DevOps is about. So let's get a little bit more practical just to, again, give you something more concrete to work with. So were you going to do this one?
Yep. So you just kind of want to dump you all into an imaginary scenario. And for those of you who are familiar with cryptocurrencies, just feel free to laugh at this because we know it's a little silly. But imagine you work for a large financial services organization. Your CEO, whomever in your organization has started to realize that, hey, these cryptocurrencies are getting big, right? And customers aren't just paying with cash anymore, right? We have Venmos, we have Bitcoin, we have all of these other different ways of making payments and transferring monies now. So CEO gets this big idea of, well, let's let customers use our banking application to pay somebody with Bitcoins. Make sense?
So,
because we can all exchange US dollars to Bitcoins, right? That's a conversion.
So that's what we want to build is a new feature to allow users, this first step of allowing users to exchange US dollars to Bitcoins. That's what we're going to build here. Something very simple. So if you're not familiar with the sort of like the Agile terminology, you usually have epics and then you have features and stories and there are other things, but we're going to just really talk about features and stories. So we have a feature that we want to develop, which is to allow our users to exchange US dollars for Bitcoin. And so we have an ID for that feature, and then we're going to create stories. Oh, sorry, the ID is for the story. We want to create stories in that. So the feature is what do we want the users to be able to do, and then the stories go a little bit more granular into what are they going to do, right? So as a user, I want to exchange US dollars in my account to Bitcoin. That's a user story in Agile. So you might store this in something like Jira. And then we'll define some acceptance criteria. So we need a conversion web page and form to exist. We need an endpoint, because this is going to be a microservice API-driven application. We're going to have a Swagger API file for the microservice. We will need the conversion endpoint that's able to convert US dollars to Bitcoin. We need the conversion web page is able to invoke the conversion endpoint with user-provided inputs. This is, again, part of this. This is what it might actually look like. But also, I just wanted to illustrate again, like even on the development side, they're pretty detailed in exactly what needs to be done, right? This is not something that security would do, is to define exactly what we're going to do. So here's a QA test that you might build for that, right? So we have a description. Exchanging US dollars to Bitcoin correctly, adjust the Bitcoin and US dollar balances in the user's account. That's what we want to verify is happening. We have related requirements or tests. So now we have, this is a test case that we're going to link back to the requirement that we just defined, which is the user story, to say that as a user, I want to exchange US dollars in my account to Bitcoin. So now we know why are we testing this, because there's a user story for it. We don't have any remote remarks or notes for this particular test case. But we do have a Gherkin script, and this is where we define what are we going to test. And so if you're not familiar with Gherkin, it's a language that's usually written in English words that has a particular syntax of given some precondition when something happens, then you expect a particular outcome, right? So you have a given that sets up the stage. When the thing is going to actually be executed, then this is our acceptance criteria that you want to validate. And we could talk through this here. So this is very commonly used by testing teams. It's used by developers with tools like Cucumber. And we use it all the time. So given the US dollar to Bitcoin conversion web page means that in a test, the first thing I need to do is open up the Bitcoin, the USD to conversion web page, right? That means that it exists, whether this is manual or automated. That's the first step. And a user account containing 0 Bitcoin and 9,000 US dollars means that I have to have an account available that meets that criteria and be logged into that account. When the user types 9,000 into the USD box and clicks convert, so if you have a Selenium script executing this, it would type 9,000 into the box and click the convert button. Or if you have a person executing this, the person would type $9,000 into the box and click convert. Then this is what we expect to happen. This tells us whether or not the test is going to pass or fail. Then the user's account page should be displayed. So that convert page will go away, user's account page will pop up, and the user's account should contain 0 US dollars because we've transferred it all to Bitcoin, and 1 Bitcoin, because that was what I'd like Bitcoin to be worth. So that tells us if the test passes or fails. So now we have an indicator at the bottom here, is this manual or automated? This wouldn't be a very difficult test to automate in particular. I mean, if you are familiar with WebDriver or Selenium, which most QA teams are, this would be a pretty easy test to automate, assuming that the environment exists. So we would automate this test, and it would run in our integration environment, and potentially other environments. Every time code is checked in, or every time that those tests are run, to validate that functionally we are able to convert or exchange US dollars to Bitcoin. Hopefully that makes sense. From the security side, we're going to follow a very similar layout from a test case perspective. Josh, do you want to talk about it?
Yeah, I'll just cover it really quick because I know we're getting incredibly tight on time. Everything here is really the same as the non-security story. But right, you see in our remarks notes, really what we're testing here is for the presence of TLS 1.2, right? So our security requirement is that we have to have TLS 1.2. And so we have additional test cases are required to validate other TLS requirements. That's important here, right? We're getting to a really small unit of work. The only thing we're testing in this test case is TLS 1.2, enabled and working, right? So we're not testing, is TLS 1.1 disabled? Is SSL v3 nuked into oblivion? Are we using only certain ciphers, right? We're very, very specific, right? And our Gherkin script here is very similar. Given the same web page, given the same account balances, the user's still typing in, $9,000 into the USD box. They're still clicking convert, right? So all of the code behind that makes the magic happen here that the QA team or the developers or whomever has already written, we're reusing that same code, right? Whoever's writing our security test case doesn't need to reinvent the wheel and rewrite that because it already exists. The only thing they have to create is the last step, right? Which is then the HTTP request should be sent with TLS 1.2. And again, it's a test that's pretty easy to automate. If we take a look at the server endpoint, and basically TLS 1.2 is enabled or it's not. If it's not, the test fails, the requirement fails, and then we report back that the application does not support TLS 1.2.
And just if you're not familiar, there's various ways to actually implement those tests technically. So like Cucumber can execute things like JUnit. If you haven't heard of BDD Security, is an OWASP project that uses Gherkin that drives OWASP Zap and some other tools, I think Selenium also, to execute security tests. So this is, you don't have to build this on your own from scratch. You can look into existing solutions and frameworks and build on them. This is just another example. I don't know if we have a lot of time to go through it.
We don't, but I think it's important to at least cover it at a high level because, in this one we're covering input validation, right? Because, hopefully one of the first things you all thought, when we gave the example of typing $9,000 into that box is, well, what happens if I type some other values into that? What if I put some script tags or something else, right? Hopefully you have some security controls in place to prevent that. But basically what we want to do here is validate that the user input defined matches a whitelist criteria. So we want them to have a number that's, they need to enter US dollars that's less than or equal to their account balance. Shouldn't be a negative number. We want it to be whole numbers only, so there shouldn't be decibels. It should be numeric only, etc. So if we look at the Gherkin script, again, first two boxes are the same. Given that we have the web page, given that they have an account balance with 0 Bitcoin and $9,000, now we want to validate against a list of input, right? So we provide a list of essentially tests to run here, right? So negative, I don't know how many zeros that is, $1 bajillion, negative 100, negative 1, 25,001, right? Assuming we have an account balance of $25,000, we want to provide something that's outside of our account balance. We've got pi there as a decimal number, and we have a string input of just dollars. So the expected result should be that when the conversion page is displayed, right, they should have an error message, right? The error message field should state, please transfer a valid quantity of US dollars. Right? So if any of these inputs are sent to our input point, and it comes back and says, hey, congrats, you've been given some Bitcoin or something to that effect, this test would fail, right? Because that input did not match our whitelist criteria.
This comes down to being very granular in your requirements, right? We need to know exactly what's going to happen, but if we do that, then we can test very well with basically 0 false positives that they're meeting security requirements. So we've only got a couple slides, but I think we're maybe over on time, so I'm going to speed through them. You don't have to reinvent the wheel with reporting. If you use existing QA tools, they're already generating reports, and they're already generating them in sort of the pass-fail language, which is what we would recommend you do. And so this is just a screenshot directly from like the Jira or from the X-Ray website, which is a test case management add-on for Jira. But I just wanted to illustrate that they show, if you're using Gherkin, you can see, right, they have this test, this part of this step passed, this step failed. So for each of those lines we had, it will show you exactly where you passed and failed. So if you have multiple criteria for a test, you'll know which ones passed and which ones aren't, which is very prescriptive in telling you what to fix. You can also get various other types of reports and dashboards at different levels from existing tools, whether it's Jira or another tool. So you don't necessarily need to reinvent reporting. Is this compatible with DevOps? Sort of spoiled this earlier. We think it's very compatible with DevOps. We're doing this right now for a very large power and utilities organization. It's working very well. Happy to talk more about that afterwards. We'll take a little more work up front, but you get really great returns on that moving downstream. And the best return is better relationships, as I think the man left, but is less tension, better relationships with the product teams, better relationships with QA. That leads to better collaboration, and working together will hopefully better demonstrate value and get you more money.
And I would even take that one step further and say that it works better in DevOps.
Yeah.
Because again, kind of getting back to the point of this slide, where now everything's green, right? You know, security is testing, right? They're embedded into the requirements gathering all the way through reporting. We have direct traceability from our requirements to our, you know, controls validation, all the way to our reports. You know, where we see a lot of organizations struggle is trying to take their existing mature security programs from waterfall and try to force them to work in Agile and DevOps, right? You know, we try to take these, you know, these slow, cumbersome tools that take a long time to run. They require manual analysis. They take expertise to review. You know, I have a client in particular that can take up to 7 weeks, you know, to do a triage of a static analysis scan, right? You can't embed that into Agile or DevOps, right? That there's no way you can make that work, right? So I would argue, you know, to Kevin's point, not only does this work with DevOps, it works better.
And 10 seconds, just next steps here. What do we want you to do? Figure out who the QA leads in your organization are, get to know them, take them out for a beer. What are their processes? What are their artifacts? What are they doing? How can you better integrate security into what they're doing? We recommend you try to do that. Build a repository of reusable, actionable security requirements that you can tag to stories and features, things like that. And then sit in sprint planning. Get to know the product teams, what they're doing, how they work, and contribute feedback as they're developing their plans. And then write your first security test case. As we said, this is not, you're not going to get this done overnight. Start with one and do it over the next X number of years until, you know, winning. Thank you, everyone.